A bus traveling at 60 km/h accelerates uniformly at 5 meters per square second. Find its velocity after 2 minutes. The first thing is we have converted the time given in minutes to seconds. Then the next thing is to now, and then we have converted kilometer per hour to meter per second. So what is next now is to use velocity time graph to solve this problem, which is one of the problems we have solved using equation of motion. Now, this is velocity axis, which is the vertical axis, and this is time axis, which is the horizontal axis. And the origin is 0, 0. Right. Now, since the balls did not start from rest, so our journey will not start from the origin, but we are going to pick a point on the vertical axis which will represent 16.7 meters per second, with which the balls start traveling. So let's assume that this point here is 16.7 meters per second. Please beware that we are not, drawing to scale. We are sketching. Now, that means the ball starts from here. Now, having started from here, so what is the next thing? Within 2 minutes, which is 120 seconds. So from 0, we'll measure 120 seconds. Let's assume that 120 seconds is somewhere here. Do not forget we are sketching. So from here to here is the time spent, which is 120 seconds. While from here to here is the velocity with which it begins the journey. Now, we are told that it accelerates at 5 meters per square second. So anything acceleration, please take note of this. It has to be drawn this way. Anything acceleration. Because when it slopes down from right to left, that is acceleration. But when anything deceleration, we have to be this way. So please take note of this. It's very important. So acceleration is always like this. Deceleration is always like this. Now, so if I want to draw the acceleration of 5 meters per square second, that means I would trace, that means there will be another velocity which we don't know yet. Why? Remember, when the body accelerates, the velocity will increase. That means within the acceleration of 5 meters per square second and within the time 120 seconds, the velocity of the body must have increased from 16.7 to another value that we don't know, which is what we are looking for. Find this velocity. So what do we do? Let me make this one to be V. So the next thing now is I will trace this 120 up to the front of this new velocity we are looking for. And I will trace that velocity also here. So it's like you are plotting a point on the graph. So you can see that this is where the horizontal and the vertical traces meet. So that means the bus is moving to this place now from here. So you join the 2 points together, because this is the starting point of the bus. This is where the bus is now within 120 seconds. And since there is no any other information given, so this is the graph. Let me call this point A and this point B. So the graph is from A to B. So how do I now find the velocity, which is V? All you need to do now is, let me label this point D and let me label this point C. So you can see that I have a kind of shape that is trapezium. Yes, C, A, B, C, D. So within this, I can carve out a triangle. Why am I carving out a triangle? because it is within a triangle. Please take note of this. It is within a triangle we can find or use acceleration under velocity time graph. It is within a triangle. So since I have acceleration, which is 5, that means line AB, which is the graph, is 5 meter per square second. So since I have acceleration, I need to draw out or carve out a triangle that will enable me to make use of this acceleration to find whatever I want. All right. Now that means I need to label this point another point, another name, A, B, C, D. Let me call here E, so that I will be dealing with triangle A, B, E. Now, whenever you are dealing with acceleration in a triangle under velocity time graph, acceleration is vertical over horizontal. Deceleration also can be found in a triangle under velocity time graph, not any other shape. You can't find your acceleration or deceleration under any other shape except a triangle. Take note of that. Now, so what is the vertical we have here now? Acceleration is 5, so I will use 5 to replace acceleration. The vertical in this triangle is B to E. That will be BE over the horizontal in the triangle is from A to E. So take note of that in a triangle, please. Now, next thing, 5 equals to B to E. Now, B, if you trace B to the vertical line, it will coincide with B. And if you trace E to the vertical line, it will coincide with what? 16.7. That means B to E means the difference between V and 16.7, which will be V minus 16.7 over A to E means the difference between A and E. And if you trace A down, that is 0. If you trace E down, that is 120. That means it will be 120 minus 0. Alright, so 5 equals 5 minus 16.7 over 120. When you cross multiply, V minus 16.7 will be 5 times 120. So V will be 5 times 120 is 600. Minus 16.7 crosses, it becomes plus 16.7. When you add up, it will give you 616.7 meter per second. You can see it gives us the same value we got when we use equation of motion. You go and check the previous lecture on equation of motion. So that is it.